Okay, class, let's go to pulse position method. So, pulse position method, almost the same lang siya sa bisection method. So, they're just same methodology. But the difference is the computation of the roots or the XR values. Okay, so pulse position method is also known as regular palsy. So, yung mga steps niya, same lang sa bisection method. So, ito yung mga steps, simple algorithm sa bisection. So, ang malahi lang dire sa pulse position method is kining XR. Then the rest, almost same lang. Okay? So, we will not conduct some example of pulse position method. So, di na tayo magbuhat og example. We'll just go to Newton-Raphson method. So, what happened kung dili given ang the boundary or the upper bound and the lower bound? So, example sa bracketing method. So, walay value ang lower bound and upper bound. So, di na to ma-solve ang problem, or so we cannot use the bracketing method. So, to be able to solve for the problems of numerical methods for finding roots of equation, we can use the open methods, or one kind of open method is the Newton-Raphson method. So it is the most widely used of all root locating formulas. So it is based on formulas that require only a single starting value of x, or two starting values that do not necessarily bracket the root. Okay, one example of an open method is a simple fixed point method. So before we will go to Newton-Raphson method, so it employs a formula to predict the root. So it is also called one-point iteration or successive substitution by rearranging function f of x equal to 0, so that x is on the left hand side of the equation, wherein so x is equal to the function of g of x. Okay, so this transformation can be accomplished either by algebraic manipulation or by simply adding x to both sides of the original equation. So one example is the x squared minus 2x plus 3 is equals to 0. So yung x, yung kanina, lalagyan lang natin dito. From left side, rearrange lang natin yung function kanina na x squared minus 2x plus 3. So x squared plus 3 divided by 2. So ito na yung function of g's of x. So ang mangyari, gagawin mo dyan, i-predict mo na lang yung roots. So example, kung ang ginamit mong value ng x is equal to 1, so x is equal to 1 plus 3 divided by 2. So anong lalabas na answer? Is equal to 2. So that is not equal. Diba? So ngayon, ang error mo ngayon is napakalaki, almost 50% error. So, pabuhin mo na naman yung value ng x. Substitute ka na naman hanggang so yung dalawang value ng x from left to the right is maging equal. Okay? So, ayun ang sample ng simple fixed point iteration. So, medyo matagal. Okay, so let's go to Newton-Raphson method. So, see the figure 6.5. So, this is the graphical depiction of the Newton-Raphson method. So, a tangent to the function of x initial, that is f of prime x1, is extrapolated down to the x-axis to provide an estimate of the root of x1 plus I. Okay, so if the initial guess at the root is at xi, so at this point, so ito yung function sa f of x. Let's say this is the expression. So ito yung graphic niya, graphs. So if the initial guess at the root at x of I, ito yung initial root. So a tangent can be extended from the point xi plus f of x initial. So this is tangent natin, diretso pag ganun, hanggang sa maging tangents. So the point where this tangent crosses the x-axis usually represents an improved estimate of the root. Okay. So the Newton-Raphson method can be derived on the basis of this geometrical interpretation. So it's an alternative method based on the Taylor series. So this triangle, so in extend siya dito from this point root. So this is the slope of f of x. So we know that this is the value of f of x initial minus 0. Okay. And this is the x initial, then this is the second term, x initial plus 1. Okay, so in extend, this is the slope. So how are we going to solve the slope? The slope of f of prime x initial. So we have this formula. So kunin natin yung muna ito in this side, f of x1 minus 0. Then this the x side, x1 minus x initial plus 1. Okay, so yun ang slope or tangent theta is equal to y over x. Okay, so which can be rearranged to yield, lipat natin to sa kabila. So x initial plus 1 is equal to x of 1 minus f of x y1 divided by f of prime x1. Okay, so transfer lang natin sa kabila dun. So this is the formula for Newton-Raphson formula. So we have here like an example. So use the Newton-Raphson method to estimate the root of f of x is equal to e minus raised to negative x minus x. So employing an initial guess of x of 0 is equal to 0. So first we will get the first derivative of this expression. So the first derivative would be f of x is equal to negative e minus x minus 1. So this is f of prime. Okay, yun. And now we will substitute the value of the first derivative to the original function formula of Newton-Raphson. So this is the original formula. So x of I plus 1 is equal to x of 1. Thus the value of the functions x of 1 is e minus ex raised to x minus x. So ito yun. Okay, then the first derivative. So ito. Ngayon sa ilalim. Minus e minus x of I minus 1. So ito yan. Okay. Now we will solve the problem using, of course, the Excel na naman. Okay, let's prepare here. We'll put the iteration or number of trials, then the initial roots. Lagay din pala natin ito yung functions kanina. F of x. Okay. The f of x. E f of prime x. is equal to e raised to minus x minus x. View. Okay, para mas madali yung computation, so we will compute this by parts. So kung para hindi mo maglisod, no? So first we'll compute for the value of f of x again sa isang column, then another one para sa f of prime x, then what else, xi plus 1, and of course we'll compute for the value of the true error and the approximate. Okay, for f of x, that is equals to negative, I have the value of e of 2.718 raised to negative xi, okay, minus 1, okay, negative 2, okay, put here the dollar sign. Okay, so xi plus 1 is equal to xi plus 1. Okay, now we'll use the Newton-Raphson formula. So this formula, okay, to compute for the value of xi plus 1, so that is equals to what, xi minus f of x divided by f of xi, f the first derivative, so that is 0.5, the value is 0.5. So dagdagan natin ng 2, okay, 3, okay. Okay, by the way, the true value of the roots, we have the true value of 0.56714329. Okay, so this is the true value of the roots. Okay, now we will compute for the true error. Okay, itong true value galing to sa book, so nakalagay sa, hindi lang siya nakalagay sa problem, naka-specify siya sa simple fixed point iteration, pero hindi na tayo nag-compute na example ng fixed point. So true error, that is equal to, let's put some abs para absolute value. Okay, true error minus the approximate, okay, divided by the true value times 100%. Okay, so this is it. Let's just reduce the point. Okay, for the approximate error, okay, for the approximate error, we have equal to the current value minus the previous value divided by the current value times 100%. So ganyan yung absolute value. So that is 100%. So now we have the second iteration. So nag-start nito sa 0, no? So that is equal to plus 1. Okay. So for the second iteration sa next step size, so what is the current value? That is equal to 0.5. Okay, so copy lang ito, drag natin. Okay, 1.6 for the value of x of 5 plus 1, 0.5660. So for the true error, M4 is M3. $. 0.15. Yan ang isa, ganun din, ma'am. Okay, so next iteration, the second hanggang ano tayo, 6. Okay, so i-drag lang nato ni ha. Voila. So okay, after the third iteration, ang error natin is nag 0% na. Let's try to increase the value. So 0 na doon siya. Okay, hanggang 4th. So pwede na tayo din tama to sa 5 and 6 iteration. So we'll already gain an error. So 0.5671 is almost close to the true value, 0.567143. So okay, so doon na to sa approximate. That's a true value. So that's it. So try to solve the problem using the fixed point iteration. Okay, and compare your the value using the method. So mas madali lang yung ano, no, Newton-Raphson method. So very simple. Okay. So now let's go to secant method. Okay, secant method, the potential problem in implementing the Newton-Raphson method is the evaluation of the derivatives. So although this is not inconvenient for polynomials and many other functions, there are certain functions whose derivatives may be extremely difficult or inconvenient to evaluate. So for these areas, the derivative can be approximated by a backward finite divided difference. So as you can see in figure 6.7, it's a graphical depiction of the secant method. So this technique is similar to the Newton-Raphson technique in the sense that an estimate of the root is predicted by extrapolating a tangent of the function to the x-axis. So however, the secant method uses a difference rather than a derivative to estimate the slope. So difference ang ginamit niya para sa pag-compute ng first derivative. So we have here the functions of x of I and the difference or backwards. So we have x of I minus 1. Okay, so same ano lang, triangle. So pag-compute sa slope sa f of x of I, so we have the f of x of I 1 minus this f of x divided by the x of I plus 1 minus x. Okay, so this is the value of x of I plus 1. So rearrange lang na po na you can get this value over the computation of the roots using the secant method. Okay, halos parehas lang sila sa Newton-Raphson. Nag-iba lang sa computation sa first derivative. Okay, so we have the another example. So same lang sa sample sa Newton-Raphson methods. Okay. So again, we will use the Excel. Excel, where are you? Okay. Okay. We will copy this one. Okay. Okay, so the problem states that the mm, so you initial estimates of x minus 1 is equal to 0 and x of 0 is equal to 1. So meron binigay na ano yung problem. So initial estimate of 0 and 1. So that is for the 0 is negative 1. Okay, we can compute for pwede natin siya ulit isa-isahin by parts or pwede rin as a buo na lang para mas madali. Okay, so we have the backward value of the x of I. So let's compute first for the f of x of I. So that is equal to e. So this is the value of f of x of I. E that is here. So we have that is equals to e. Equal to e. Ito yun raised to negative x minus, okay, then for the f of x of I, that is equal, yeah, so that's equals to e raised to negative x. So this is the backward negative minus x. So 0. Okay, that is 1. Okay, for the x of I plus 1, that is equal to x of I is e8 minus, hindi lumalabas, wait lang, it's equals to x of I, so this formula minus f of xi, okay, times xi minus 1, so that's the backward 0 minus x of I to, okay, close parenthesis, then divided by f of x I minus 1, so we have the g8 minus f of xi, so this is f8 close. Okay, that's it and enter. So we have the value of x of I plus 1, which is equal to 0.6127. Then of course we will compute for the true error and the approximate Okay, now let's go to the next iteration. So maging x of I niya karon is a current value. Okay. Okay, for true value, so we have the true value 0.5678 minus the current value divided by true value times 100%. So kung nagyapan siyang absolute value, so okay, we have an error of decrease na 8.03%. Okay, for the approximate error. Okay, approximate error is equals to new value, okay, minus the old value divided by new value times 100%. So, iliit natin yung absolute para positive ang ibigay niya na result. So, we have 63.21% for the approximate error. Okay, now let's go to the second iteration. So, ang x of I, so maging final niya ngayon is itong value na to, 0.6127. Then the initial value would be 1. Then i-drag lang natin yan hanggang pababa. Okay, so 0.58. Then the next iteration, that is second na naman. So ito yung value niya is equal to that. Okay, let's compute. Okay, then next iteration, third and fourth. So let's drag lang natin yan. Okay, so we get it here. On the third iteration, we already had a true error of 0 and approximate error of 0. Then the roots of equation is almost near to the true value of 0.56743. So no need to compute for the other iteration kasi ano na, halos malapit na sa true value. So that's it. So that is the roots of the equation. Okay. So that's it. Okay. So second method lang, backwards lang ka ng isang step. Okay, then you have your assignment. So submit your assignment under assignment number 4 sa LMS Canvas. Okay, so that's all for today. So if you have questions, just leave a comment sa comment sections.